In the last lesson, we looked at arithmetic sequences, which were lists of numbers that go up by the same number or go down by the same number, having a common difference. In this lesson, which is about arithmetic series, we're going to look at what happens if you start at the first number and add up all of the numbers in an arithmetic sequence to a certain point. This is a way that we can try to take something that had a pretty distinct pattern and see if we can extend the pattern to something more complex. In this case, adding up terms in a sequence as opposed to just listing them. So let's take an arithmetic sequence with which we're all pretty familiar, the numbers 1 to 100. 1, 2, 3, 4, 5. We have a first term, which is 1. We have a common difference. Common difference is also 1. We're going up by 1 each time. So just the list of numbers from 1 to 100 is in fact an arithmetic sequence. So we're going to try to add those numbers up. So adding up all the numbers from 1 to 100. And a mathematician called Carl Gauss came up with a method for doing something like this. And so his method was to list all of the numbers in ascending or going up order, and then to list the numbers again, but this time in descending order. So we have our sum, which is 1 plus 2 plus 3, etc., plus 4 plus 5 plus 6, all the way up to plus 99 plus 100. And then we're going to list it backwards. So 100 plus 99 plus 98 plus all the numbers in between, plus 3 plus 2 plus 1. And we notice when we line the numbers up back to front that each individual sum, so we have 1 plus 100, 2 plus 99, 3 plus 98, they all add up to 101. So that's lovely. So if we have 100 numbers in this sequence and we're adding them up, we have 101 that we're going to be adding 100 times. Notice though, this answer that we get is going to be 2s. It's going to be double what the sum is that we're actually looking for, because we're adding up 1 to 100 and then we're also adding up 100 to 1. So when we add 101 100 times, we get 101. 100, didn't even need a calculator for that one. And so the actual sum, this is double the sum of the numbers 1 to 100. So half of that, or 50-50, will give us the sum of the numbers from 1 to 100. So we are going to define an arithmetic series as the sum of the first n terms of an arithmetic sequence. We're not starting anywhere in the sequence. We're starting always with the first term and adding them up to whatever point we would like. The sum, we have two formulas for the sum. So the first formula is the formula we get using Gauss's method. And that we can actually add up. So if you have T1 plus T2 plus dot 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 plus T sub n, and then you have T sub n plus T sub n minus 1 plus dot 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 plus T sub 1, we find out that actually these are all equal to the same thing for any arithmetic sequence. So what happens is we are going to take the total number of terms in the sequence, divide it by 2, and use that times the first term plus the last term, which is essentially exactly what we did for Gauss's method. We did 1 plus 100, and then we actually multiplied it times 100 and then divided by 2, which is where we get our n over 2. S sub n, the first formula, essentially is the same as the second formula, just instead of writing T sub n, we use our original formula. Remember, our formula for T sub n equals T1 plus n minus 1 times d. And you can actually see that formula inside. We just have an extra T1 here. So if we plug our formula for Tn into that second formula, we can simplify it to get the first formula. So they actually aren't really different formulas. It's just whether or not you want to find Tn using the Tn formula or whether you want it embedded in your series formula. Okay, first example, just a straightforward problem. We're going to determine the sum of the first 12 terms of the arithmetic series. This, using the formula, is just a shortcut. We could theoretically write out all of our arithmetic sequence and add up all the numbers. Just we'd have to write out 12 of them and it would take some adding. So what we're going to do, and you can see why some of these methods came about, particularly if you think about the days before calculators existed. So let's take a look. We have T1 is equal to 3. Our common difference, we have going from 3 to 9, 9 to 15. Our common difference is 6. Our n, we're trying to find the first 12 terms, so n is going to be 12. And our t sub n, we actually don't know. We don't know what the 12th term is. So we have a choice. We can either find Tn using the Tn formula and use the second formula. I prefer just to use the first formula because it has that calculation embedded inside. So S sub n is n over 2 times 2 t sub 1 plus n minus 1 times d. So now I'm going to replace, so we're looking for S sub 12. And so our S sub 12 is 12 over 2 times 2 times 3, that's our T1, plus 12 minus 1 times 6, which is our common difference. And we can simplify that, so we get 12 over 2 is 6. 6 plus 11 times 6, that's 6 plus 66, which is 72. That's 6 times 72, and that works out to 432. And so the sum, and remember what we're getting. When we have an S, we're getting a sum. So that means the sum of the first 12 terms, we're adding up the numbers 3 plus 9 plus 15 plus everything else in that arithmetic sequence up to the 12th term. And we actually have gotten the sum without, we still don't know exactly what the 12th term is, but we were able to calculate the sum regardless. Example 2. Find the sum of the terms in the sequence 17, 12, 7, negative 38. So we're going to write down what we have. We know T1 is 17. We know our common difference. Well, we're going 17 to 12 to 7, so we're going down 5. That makes our common difference negative 5, because if we're going down, it's always a negative common difference. Our nth term, so our t sub n, we don't know how many terms there are in this sequence. So we actually don't know n at this point. But we know what the nth term is, the t sub n. We know that our last term here is negative 38. So if we're doing our last term, the nth term is going to be, so 1, 2, 3, and then that's our n. So we want to figure out what the sum of those first n terms is, okay, even though the sequence is ending at the n. So here's the issue. We can write down our formula. So we have our formula that says S sub n equals n over 2 times T1 plus T sub n. So since we know T sub n, we may want to use this formula. However, you notice this formula actually also has an n in it. So we can't get away without finding n. So the first thing we actually have to do is go and figure out how many terms there are in this sequence before we can proceed with finding the sum. So what we're going to do is put this formula right here on hold for a bit, and we're going to go back to our term formula. We have T sub n is T1 plus n minus 1 times d. So I'm going to replace my Tn is negative 38, my T1 is 17, and times n minus 1, my d is negative 5. And this is personally why I write all of these things down on the side, because that way once I get my formula down, I don't have to think quite as much about what goes where. So now I'm going to simplify all this. I'm going to subtract 17 from both sides, so I get negative 55 is n minus 1 times negative 5. Divide by negative 5, I get 11, and that equals n minus 1. Generally, if it's a legitimate sequence, you'll know if you're doing something wrong if you get a negative number for n. N should always come out positive. Okay, we're going to add 1. Don't know why I'm showing it in such great detail, but enjoy my adding 1. And we have 12 equals n. So we're not done. We still have to find the sum. So we're going to go back to our s sub n is n over 2 times t1 plus t sub n. And so now we know that n is 12. So our s12 is 12 over 2 times 17 plus negative 38, which gives us 6 times negative 21, and that works out to negative 126. And that makes sense. Our sequence is, we're starting at 17, we're getting to negative 38, so it seems like there's going to be more negative numbers in the sequence than positive numbers, so for them to add up to a negative number makes sense. All right, let's look at another example. The sum of the first 4 terms of an arithmetic series is 246, and the sum of the first 8 terms is 380. What's the general term for the corresponding sequence? So this looks like it's going to involve some, again, we have something about S4, not T4 this time, but S4. We've got some information about S8, so it looks like we're going to end up with some kind of systems of equations problem. So let's take a look at how we can set that up. So we have S4 is 246, S8 is 380. So we've got 246. Let's write out a formula for this. So I'm going to use the formula because I don't know Tn for any of these. So I'm going to use the formula that doesn't involve Tn. So we're going to be using the formula S sub n is n over 2 times 2t1 plus n minus 1 times d. Okay, so 246, we'll replace that. That's our s sub 4 is equal to 4 over 2 times 2t1 plus 4 minus 1 times d. Okay, so that's my T4, and I'm going to do the same, S4, sorry, and I'm going to do the same for S8. So my S8 is going to be, I'm going to simplify it. Let's simplify this first. So we get 246 is 4T1 plus 6D. That's going to be a little easier to work with. Let's do the same for my S8. So we've got 380 equals 8 over 2 times 2t1 plus 8 minus 1 times d. And so we get, simplifying, we get 380 equals 8t sub 1 plus 28d. So again, I've got my 2 equations with 2 variables, and I kind of knew this was going to happen when I didn't know T1 and I didn't know D. I didn't know enough about the sequence to do anything else. And this, in fact, I don't even know the terms, I just know the sums. So now we're going to try to work out what D is, or what T1 is. So what I'm going to do, this doesn't, because we're using the sum formula, this doesn't line up for an easy elimination like the term formula, but I notice if I multiply my upper equation by minus 2, then I will get a negative 8t1, and I can actually just add the 2 equations together to eliminate the t1s. So that's what I'm going to do. So when I do that, I get negative 492 equals negative 8t1 minus 12d. And I'm going to write my other equation below it. I don't need to multiply that one by anything because my minus 8t1 and my 8t1 will line up. Get plus 28d. Then I'm going to add. I get negative 112 equals t1s eliminate, and I get 16d. Dividing by 16, I get d equals negative 7. So now I'm being asked what's the general term. So to find the general term, I still need to know T1. So I'm going to just use one of my original equations. 246 equals 4T1 plus 6D. That is a wonky D. Let's redo that. So 246 equals 4T1 minus 42. Minus 7 times 6 is minus 42. Add 42 to both sides. We get 288 is 4t1, and 72 is equal to t sub 1. So if I'm going to write answering my question, the general term is t sub n is 72 plus n minus 1 times negative 7. And that's how I work through that kind of a problem. And we're actually going to have to do that again for the next word problem. So let's take a look. A school is collecting bottles and cans for a charity event. The number of cans the school collects each day forms an arithmetic sequence. By the end of the third day, the school had collected 540 cans in total. And by the end of the seventh day, so third day, 540 cans, and by the end of the seventh day, the school had collected 1820 cans. So because we're talking about the total number of cans they've collected, we know that we're not talking about terms here. We're not talking about how many cans they collected on the seventh day. We're talking about the total over the 7 days. That's a clue that we're talking about a sum and not a term. So we have a similar setup here. So I know the sum at the end of the third day was 540, so that's my S3 equals 540. The sum at the end of the seventh day, that's my S7, is equal to 1820. So I'm going to set up an S3 equation. So my S sub 3 is 3 over 2 times 2t1 plus 3 minus 1 times d. And I'm going to replace S3 with 540 because that's what it's equal to. So I get 540 equals 3t sub 1 plus 2d times 3 halves is 3d. And now I'm going to do the same for my S7. So S7 is 7 halves times 2t1 plus 7 minus 1 times d. I'm going to replace my S7 with what its value is, which is 1820. And then simplify all these lovely numbers in here. And I get 7t1 plus, that is 6d, so I get 6 times 7 halves, which is 21d. Okay. So now I have 2 equations and 2 variables. Here, I could try to multiply by -7 to get the d's to go away. I'm going to try something else, which is to use substitution, just to review another method of dealing with systems of equations, which is what we are doing here. So what we're going to do is we're going to take this top equation and we are going to isolate one of the variables. So the first thing I'm going to do, I notice that 540 is divisible by 3. So I'm just going to divide everything by 3. So I get 180 equals t1 plus d, just by dividing the whole equation by 3. Now I'm going to subtract d from both sides, and I'm going to get 180 minus d equals t sub 1. So that's the value of t1. I could have done it the other way, doesn't really matter. So now what I'm going to do is in my other equation, I'm going to replace t1 with 180 minus d. So I'm going to use my 1820 equals 7t1 plus 21d. Then I'm going to replace that, and I get 1820 equals 7 times 180 minus d plus 21d. Then simplifying, I get 1820 equals 1260 plus 14d, because we have minus 7d and plus 21d. Subtracting 1260, I get 560 equals 14d, and dividing, I get 40 equals d. So now we have to look back at the word problem and figure out what exactly I've calculated. I've calculated the common difference. So that's the amount that the number of cans collected goes up by each day. It's not the amount the total goes up by each day, it's just the amount that the number of cans goes up by each day. So the question is also asking me to list how many cans the school collected each day. So I actually have to write out, what it's asking for is it's asking me to write out the whole sequence from day 1 to day 7. So what I'm going to do is I'm first going to calculate T1, which is pretty simple because I have my lovely equation 180 minus D equals T1. So T1 is equal to 180 minus 40, which is 140. So now what I'm going to do is I'm going to actually answer in a chart. I'm not going to bother writing the general term because the general term is not what I'm going to be asked for. So I'm going to make a little chart that says day and cans. And then I can list day 1, 2, 3, 4, 5, 6, 7. I can fill in my chart. You don't necessarily have to make a chart, but you do need to give the same information that's in this chart, which is how much was collected on each day. And so I'm actually listing out the first 7 terms of this sequence, not the series. The series is what it would add up to after that many days. So we have 140, 180, 220, 260, we're adding on 40 each day, 300, 340, and 380. So now at this point, we have actually finished this problem and answered it in a form that responds to the question properly. So generally for word problems, we're going to be looking more at mixed word problems towards the end of the unit, but with word problems, it's really important to differentiate whether you're being asked about a term, so like what the number in the sequence is, or a sum, which is adding up all of the numbers in the sequence to that point. So generally, if you're asked for like a total, that's going to be a sum. If you're asked just for on that day or at that time period, you're being asked for a term. So that's the thing that it can be really tricky to do. We also have our two different formulas for sums, which are used for different things. For these problems, we used only the first formula because we didn't want to have to additionally calculate t sub n, although you can do that using your t sub n formula. The thing we have to be careful about is that first formula, if you try to use it to find n, you will end up with a quadratic equation in n. So unless you love quadratics, don't try to use that first one to find n. If you know the first and last term, you can use the second formula to find n, and you may need to work out some other things using your term formula. All right, next up, we are going to be looking at a different kind of sequence to arithmetic.